5.1 Mid-segment theorem and coordinate proofs. Vocabulary. A mid-segment of a triangle. A mid-segment of a triangle is a segment that connects two sides of a triangle from their midpoints. So it connects the midpoints of a triangle and if you want to see that, we can draw any triangle that we want and figure out where the middle would be on each side and then draw in the mid-segment. You can continue to do this all the way around the triangle if you'd like to get another triangle on the inside. Okay, coordinate proofs. That's a proof that involves placing a figure on a coordinate plane. From there, you would usually use the distance formula and the slope formula to prove something else. Okay, theorem 5.1, the mid-segment theorem. The segment containing the midpoints of two sides of a triangle is parallel to the third side and is 1/2 as long as that side. So DE is parallel to AC and DE is 1/2 of AC. Okay, example 1. Window. Large triangular window is segmented as shown. In the diagram, DF and EF are mid-segments of ABC. Find DF and AB. Okay, D to F. Well, if you look at D to F, it's the midpoint of B to C. So D to F equals 1/2 of B to C. And so that is 1/2 of 90 or 45. A to B is the whole thing of FE. So we want twice now of the small FE to equal the large AB. So 2 times 45 or 90. Checkpoint. In example 1, consider the triangle ADF. What's the length of the mid-segment opposite DF? Okay, start the video again when you're done. Okay, in the diagram at the right, QS equals SP and PT equals TR. Because QS is SP and PT is TR, S is the midpoint of QP and T is the midpoint of PR by definition. Then ST is a mid-segment of PQR by definition, and since QR is parallel to ST, let's go ahead and mark that. QR, little triangle symbols, are not triangle, more like arrows, aren't they? QR is parallel to ST. There you go. Then, by definition, and QR is parallel by the mid-segment theorem. So if they're parallel and they split it a side in half, then you know that it has to be half of the long one. Okay, go ahead and do that checkpoint. Let's look at example 3. Okay, place a figure in a coordinate plane. Place each figure in a coordinate plane so that it's convenient for finding side lengths. Assign coordinates to each vertex. A square. Now, if I draw a coordinate plane, technically I could put my square anywhere in here, and that would be legal to do. But there is one place that's really easy for it to be, and that is lined up with the origin, because you know one point already would be 0, 0. Okay, so it's easy to find the lengths of horizontal and vertical segments in distance from 0, 0. So place one vertex at the origin and one or more sides on an axis. Let S represent the side length, and you need to use 3 different variables on B. Okay, so let's look at how they set up this A. From 0, 0, and then you would draw one side of your square, and you would say that that side's S long. So that's how they got the coordinates S0. Now they put the other side on the y-axis, and they said, well, it's 0x, but it goes up to S on the y-axis because it's square, so all sides have to be the same. That means that the fourth corner, fourth vertex, is S over, and then S up, so its coordinates is SS. That's really easy to use a distance formula and prove a lot of things with it. Okay, on this triangle, since it's a equilateral triangle, well, we don't know that it's equilateral, it's a acute triangle. There's not a really great way to put it. If it was a right triangle, you see that it would be easy to do this with it. But with a acute triangle, I'm going to have to put this other H in here. Okay, and so I have to use B as this side length, and then I have to say that it is a certain letter up, so A, and then it's a certain letter across to get here, so H. Example 4. Apply variable coordinates. In example 3, part A, find the length and midpoint of a diagonal of the square. Well, we go ahead and set the square on the origin and put in all our S's. And then we're going to find the distance from B to D by using this distance formula. Remember, the distance formula is part of the Pythagorean theorem. So how long is it from D to C? Yes, it's S, isn't it? Because we take S and we minus 0 to get S. How long is it from C to B? Well, we do the same thing with the Y's. So S minus 0 is S. So the distance formula would be S minus 0 squared plus S minus 0 squared. That would be s squared plus s squared. And do you remember what that would be? A common mistake would be to say that's s to the fourth. But we don't have a multiplication sign in there. We have an addition sign. So what we have is 2s squared. And we can go ahead and pull that s squared out, because what's the square root of s squared? That would just be an s. So that whole thing equals s times the square root of 2. Okay. Use the midpoint formula to find the midpoint of m. Remember the midpoint? You add up the x's and divide by 2, and add up the y's and divide by 2. So here are our points again. 0, 0, and s, s. So our midpoint would be s plus 0 over 2, and s plus 0 over 2 are just half of s and half of s. Okay, try these two checkpoints and you'll be done with this lesson. Now, this is a pretty easy lesson, isn't it? But every section in this chapter, we're going to have a lot of vocabulary. So you really need to keep your focus on what all the vocabulary words mean. So if I'm talking about mid-segment, I'm talking about connecting the midpoints on a triangle. And that mid-segment will be half of the length of the opposite side and parallel to it.